Question number 2 also requires you to be kind of clever. You know that we need to get to the fact where triangle HCE is isosceles. And HCE is this whole big triangle. And what I am going to guess is that we need to prove two sides congruent. So what I'm going to aim for is that CE is going to be congruent to CH. But for me to do that, what I'm going to aim for is proving that angle E is congruent to angle H. And as far as angle E is concerned, I notice that angle E and angle H happen to be angles in triangles. So I'm going to redraw this. So what I'm interested in is triangle EDG and also triangle HFJ. So I'm aiming for these two triangles. So triangle EDG congruent to triangle H, let's see, ED, so HJF, if I rewrite those. So I'm trying to show that those are congruent. And the reason that I chose those is because, in fact, we have some information. We know DG is congruent to JF. We know DE is congruent to JH. And we also know that EG is congruent to FH. So right away, based on what we're given, we can just kind of cut right to the chase. We know that we have enough information to say that these two triangles are congruent by side, side, side. And then by CPCTC, our angles are congruent. But then if we step back and we just look at what we have in this triangle, so again, I'm going to step back and just look at the triangle here. This big triangle is what we're interested in, and we just showed that we have a pair of congruent angles. So therefore, the sides opposite them must be congruent. So this again is the isosceles triangle theorem converse. We're going from knowing that we have congruent angles to congruent sides. But then once we have a pair of congruent sides, we can conclude that our triangle is isosceles. And we're done with question 2.